So next we are going to be moving to the electrical test. On the electrical test, we are going to be carrying out a few tests which is similar to the ones that we've seen in other electrical equipment before. Okay, so we'll be doing the resistance test. We'll be doing that resistance test on both connections. We'll also be doing the resistance test on the contact to see that there are no unnecessary resistance developing on the contact. We'll also carry out the insulation resistance tests between the phases and between phase and ground, and some other tests on the circuit breaker that we'll see as we go along. So we want to perform the resistance test, and we are going to do so with the use of a low resistance meter, very low resistance, a micro-ohm or milliohm meter. So we are performing this test on both connections and also on the contact. Okay, so like in this case now, if this two terminal is accessible, we can close the circuit breaker and then put one of the probe here and here and measure the resistance. So that will give us the effective contact resistance. As usual, we want it to be as low as much as possible. Should be zero, as close to zero or zero. Then we want to also perform insulation resistance test. The insulation between the phases, between phase 1 and 2, between 1 and 3, and 3 and 2. Okay, and then each of the phases to ground. So we'll do that when the breaker is closed, and when the breaker is open, we want to test the insulation between the contact. Okay, that is across each of the phase. So that will give us the effective insulation resistance of the insulating material, which is the oil in this case now, in the circuit breaker. So we'll test for the first contact for line 1, test for the second contact, and then the third contact. So we want to be sure that all of them meets what is specified by either the manufacturer or one that is specified in our facility. So in case that we do not have, we can use this table as shown. So this is an example of this is a micro-ohm meter that we can use to do our insulation, our resistance tests. Okay, so this is the table. So since we are looking at medium and high voltage, so these are the voltage region that we'll be looking at. Okay, from 1000 volts and above to about 60, or let me say about 34,000. That is from 1000 volts, because we are looking at medium and high voltages. So these are the test voltages, and this is the minimum insulation resistance we should expect to have when we carry out the insulation resistance test. So we can use this table as a guide to know when our insulation is failing. So the next test, as we said before, we want to perform the contact pole resistance. We can use this low resistance meter like this when the contacts are closed, so we can probe these two terminals. Okay, that will give us the effective resistance. So we'll do it for line 1, line 2, line 3 to give us the resistance across the poles, as we said earlier before. Then on the control wiring, we want to also carry out the insulation resistance to ground, but we need to be very careful. We need to follow the instruction of the manufacturer in case we have sensitive digital devices, okay, in that control circuit, so that we do not go and damage them. Then the oil too, we want to take a sample of the oil and then test the sample of the oil. We'll test for the dielectric strength of the oil, that is the breakdown voltage of the oil, in accordance to ASTM D877. So that is what we want to do. We also want to look at the color. So the color should be as bright as possible, as recommended by the ANSI or ASTM D1500 standard. Okay. Then we also want to test the power factor that has to do with the insulation too of the oil. So we test that. Then the interfacial tension, we also want to look at that. Then the condition that we can see physically of the oil, we also want to take note of that in accordance with that standard. So the other test that we want to do using the circuit breaker analyzer is the minimum pickup voltage. Okay, and we are going to do that on the trip coil and the closing coil, the minimum voltage that the coil will actually be energized. Okay, so we are going to check for that. Then we also want to verify that all the auxiliary features, okay, such as the close and the tripping features of the circuit breaker associated with the circuit breaker, is operating properly. Then next we can look at the trip circuit. Okay, so we want to operate the protective device to see that the trip circuit will actually respond. So all of those we can simulate some fault condition with the circuit breaker analyzer to see that the circuit breaker will actually trip when such condition is so the logs that we have in the protection, we can download them, and then if possible we can reset all the trips log, or we just leave them in the memory. Okay, and then if there are the ones that will prevent the equipment from functioning properly, we want to reset the equipment back to the factory, that is back to what we feel is normal for our operations. We also perform power factor tests, which is also an insulation resistance test. Okay, so for the power factor test, if you are not too familiar with it, you can check the description below for a link to our training on the TAN data tests, or the power factor test and dissipation factor tests. Okay, then you will also perform the dielectric withstand voltage test. So we subject it to a very high voltage, more than what is normal, and then see if the insulation will be able to withstand that voltage. So all of them are basically to check the integrity of the insulation of the circuit breaker.